Okay, this one is again from H.C. Verma. Okay. A rod of placed along the x-axis between x equal to 0 and x equal to L. The linear density, that is mass per unit length rho of the rod, varies with the distance x from the origin as rho equals a plus bx. Find the SI units of A and B. Find the mass of the rod in terms of A, B and L. I think this is a pretty simple problem. Let's first go to A. Rho is equal to A plus bx. The dimensions of LHS, please don't take them as ml raised to negative 3. It is mass per unit length, so ml minus 1, right? So dimensions of A must be m1l minus 1, right? For dimension and homogeneity. Now this term has dimensions of length. Which one? X. X has dimensions of length. So what should be the dimensions of B? Anyone? It has to have dimension of mass 1. But what has to be its dimension or power of L here? Yes? To make it dimensionally homogeneous, the equation, what should be the power of L? Negative 2. Correct. Negative 2. Okay, negative 2. Fine. So dimensions is clear. Okay, they are asking us to find SI units. Okay, SI units. So what are the SI units of A? A kg per meter. And B has to be kg per meter square. That's fair enough. Okay. Number 2. Find the mass of the rod in terms of A, B and L. This requires integration. Okay. Now see. They are saying that the rod is placed along x-axis between x equal to 0 and x equal to L. Suppose this is the rod. This is y-axis. This is the vertical line x equal to L. And suppose this is our x-axis. Okay, this is our x-axis. 0 and L. Now the problem is, we cannot just multiply the density of this particular rod by the length to get its mass, because the density varies with distance, right? The density varies with the distance. Okay, so we have to integrate. Please understand the reason of integration being used. Okay, why are we using integration? Because density is not uniform, it is not constant, it changes with location. Okay, so we now say total mass is equal to sum of individual masses. That is what integration is all about. If you cannot find it totally, split it into smaller masses and get the answer, right? So suppose I pick a mass here. Suppose I pick a small portion here, dm. Okay, what will be the mass of this particular point or length? Now we can either pick the left limit or the right limit. Let's pick the left limit here. Let this be at a distance of x units from the origin. Now if it is at a distance of x units from the origin, can we find its length? Can we find its mass? Yes. Its mass will be given by the density rho into length. Now please note, here we should not take length as x. We should take the length of this small segment. Okay, and let's choose that length as dx. Have you followed this? You have. Okay. So what is the total mass? Sum of individual masses. So as we decrease these delta x's, okay, as we decrease this interval delta x's, we have to integrate and take limit and add. So total mass m will be integral of a plus bx from okay, from 0 to L. Integral of a is ax, So AL, integral of bx is bx squared by 2, so bl squared by 2.